From space, Earth shines like a blue jewel. But that blue, so familiar at first glance, hides a world few truly know. Because most of our planet belongs to a realm the human eye has never directly seen: the oceans. 71% of Earth's surface is covered in water. Yet only a small fraction of these waters has been mapped. Scientists estimate that over 80% of the ocean floor remains unexplored. That means most of our planet is a place no one has ever truly seen. In these depths, where light penetrates only about 200 meters, everything slowly fades into darkness. After 1,000 meters, an endless night begins. Every centimeter of water is pressed by the crushing weight above. And within that darkness, at the very bottom of the world, lies its deepest point, the Mariana Trench. Around 180 million years ago, Earth did not look as it does today. The continents were joined together in one vast landmass, Pangaea. But the planet's crust is not still. It drifts slowly and silently, carried by gigantic tectonic plates. These plates grind, collide, and pull apart, shaping the very face of the Earth. This movement is known as tectonic activity, and the story of the Mariana Trench begins right there. The Pacific Plate is being forced beneath the Philippine Plate. This process, called a subduction zone, bends the seafloor downward, carving out the deepest scar on our planet. The Mariana Trench stretches roughly 2,550 kilometers, and its deepest point, Challenger Deep, reaches about 10,984 meters. Recent measurements even suggest it may extend beyond 11,000 meters. To put it simply, if you were to place Mount Everest upside down inside the trench, its summit would still be submerged by nearly 2 kilometers of water. It is, quite literally, a world below every mountain on Earth. In 1872, humanity decided to venture into the deep for the very first time. The HMS Challenger, a British Royal Navy vessel, set out on a global expedition to chart the seafloor and study ocean temperatures, currents, and marine life. Technology at the time was primitive: a rope, a weight, and patience. Researchers would lower the rope, wait for it to hit bottom, then measure its length. It was a simple yet revolutionary method. In one location in the Pacific Ocean, the rope kept descending. 2,000 meters, 4,000, 6,000. The wet line groaned under its own weight as sailors watched in silence. Finally, it stopped. The measurement, 8,185 meters. The deepest ever recorded at that time. And for the first time in history, the world heard the name: Mariana Trench. This discovery was more than a depth reading. It was the birth of oceanography itself. The first time humanity dared to say, "I can measure the unknown." By the mid-20th century, science was no longer driven solely by curiosity. It was fueled by power. During the Cold War, as the United States and the Soviet Union raced to conquer the skies, the depths of the ocean became a hidden battleground. Sonar technology was developed during this era, originally to detect enemy submarines. But it also allowed scientists to map the shape of the ocean floor. Sound waves were sent downward, bounced off the seabed, and returned. The time it took to return revealed the depth. In 1951, the HMS Challenger 2 used sonar to re-measure the trench. Result: 10,900 meters. This was the first measurement confirmed by modern science. That deepest point was named Challenger Deep. The deepest place on Earth now had an identity, but one mystery remained. No human had ever been there. In the late 1950s, Swiss physicist Auguste Piccard had a radical idea that changed deep-sea exploration forever. If a balloon can withstand the pressure of the atmosphere while rising into the sky, he thought, why couldn't one withstand the pressure of the sea while descending beneath it? From that idea came the bathyscaphe Trieste. Its core was a small steel sphere, a pressure-proof capsule for 2 men. Above it was a tank filled with gasoline, lighter than seawater, allowing it to sink and later rise by releasing ballast. The US Navy bought and upgraded the craft, preparing for a historic mission. On January 23, 1960, Jacques Piccard and Don Walsh descended into history, the first humans to reach nearly 11 kilometers below the surface. The journey took about 5 hours. In the trembling silence, they reached the bottom. What they saw stunned the scientific world: a soft grey seabed and a white, flat creature gliding slowly across it. A fish, in a place where life wasn't supposed to exist. According to textbooks, bony organisms should have been crushed by 1,000 atmospheres of pressure. Yet life had found a way. Piccard wrote in his log, "Life appeared where we least expected it." Perhaps life cannot be destroyed at all. The lowest region of the Mariana Trench is known to scientists as the Hadal Zone, named after Hades, the god of the underworld. It is, in many ways, Earth's own aquatic version of hell. Temperatures range between 1 and 3 degrees Celsius. The pressure is about 1,100 times greater than at the surface. A human body would be crushed instantly, like steel under a giant's hand. Yet for microorganisms, it's home. Here, researchers have discovered piezophilic bacteria, organisms that thrive under extreme pressure. Their membranes protect DNA from deformation, and special enzymes prevent their proteins from collapsing. Some species even generate energy using methane and sulfur instead of sunlight. This is one of the strongest proofs that life can exist without the sun. That's why, when scientists search for life on Europa, Jupiter's moon, or Enceladus, Saturn's moon, they look first to the Mariana Trench. Because there, the limits of life have already been redefined. The year was 1997. The NOAA, the US National Oceanic and Atmospheric Administration, detected something in the southern Pacific. Or rather, something so deep it could barely be heard. The signal was so powerful, it was recorded by sensors 5,000 kilometers away. It began as a low rumble, then swelled into what sounded like the roar of a colossal creature rising from the abyss. Scientists named it the Bloop. Early analysis suggested only a massive organism could make such a sound, larger than any whale. Some speculated about an undiscovered leviathan, but science advances through evidence, not imagination. After years of study, NOAA offered an explanation. The bloop, they said, likely came from icebergs breaking apart near Antarctica, a sound of nature, not of life. Yet not everyone was convinced. Frequency maps hinted that the source aligned with resonance zones beneath the Mariana Trench. Even today, some researchers believe the sound's true origin remains a mystery. Perhaps the Earth still speaks to us from the depths, and we simply don't yet understand its language. The Mariana Trench astonishes not just with its depth, but with its biodiversity. Since the 2010s, deep-sea expeditions have discovered hundreds of new microorganisms, some transparent, some glowing, some feeding on metal ions. One of the most striking findings was a group of tiny crustaceans called amphipods. Within their bodies, scientists found polyethylene-like compounds, plastics created by humans. Even here, in Earth's most remote place, human pollution had arrived. A silent warning. Humanity leaves footprints, even where no one has ever walked. Yet from this pollution, science found hope. Certain bacteria were able to break down plastic naturally and convert it into energy. These organisms may hold the key to future biotechnological solutions. Perhaps even in the deepest darkness, life is trying to help us. In the Untold depths of the Mariana Trench, no sunlight penetrates. But some creatures create their own. This phenomenon is known as bioluminescence. Bacteria, plankton, and even predatory fish produce light through chemical reactions. Some use it to lure prey, others to evade predators. A single blue shimmer drifting through black water looks like a lone star in space. It's as if nature learned not to fight the dark, but to live with it. The enzyme luciferase, responsible for these reactions, has revolutionized medicine and genetics. Today, scientists use it to map cells and detect diseases. In other words, the light of the deep sea now helps save human lives. In the 21st century, technology reopened the gate to the abyss. In 2012, filmmaker James Cameron descended solo to the bottom in his submersible, the Deep Sea Challenger. Only cameras, sensors, and his heartbeat accompanied him. During the 7-hour mission, Cameron filmed new species, minerals, and sediment structures in unprecedented detail. Upon surfacing, he said, "Down there, even silence was under pressure. It felt like another planet." In 2020, China's submersible Fendouzhe reached 10,900 meters, carrying 3 scientists. Their cameras captured drifting microorganisms, gas vents, and thermal hotspots, evidence that the trench plays a role in Earth's heat balance and global climate. The Mariana Trench, it turns out, is not just a hole. It is one of the planet's beating hearts. Exploration continues. Joint missions by NOAA and NASA now deploy autonomous robots to collect data where humans cannot go. They study the chemistry of the water, the behavior of microorganisms, and the vibrations of sound itself. Some findings suggest there may be hydrothermal vents within the trench, volcanic-like fissures spewing hot mineral water. Around them, bacteria thrive without sunlight, drawing energy from the Earth's internal heat. This resurrected an ancient question. Could life itself have begun in places like this? If so, life might not need the sun at all. Only energy, chemistry, and time. And that means life could be far more common across the universe than we ever imagined. The Mariana Trench is more than rock and water. It is a mirror of human curiosity, a test of how deep we're willing to go to understand our world. Every diver, every robot, every microphone is asking the same question. What lies beyond the known? For thousands of years we've looked up to the stars, but perhaps the greatest discoveries don't wait above, they wait below. In a realm where no sound echoes, no light reaches, and no civilization leaves a mark, only silence remains. And within that silence, we might just hear the truth of who we are. Maybe the answers aren't in the heavens, but in the depths. Because sometimes, to hear the truth, you must first learn to descend into silence. Our journey into the depths was not only a step toward understanding the ocean, but also a step toward understanding ourselves. What we hear in silence often speaks louder than words. If you enjoyed this voyage of discovery, don't forget to subscribe, like the video, and turn on notifications so you won't miss the stories hidden beyond the silence. Because in this world, there is still so much left to discover. One world wisdom. Wisdom begins in the depths.